Hey, you guys. So this unit, we're going to start talking about um, the what's called the Big Bang theory, and what sort of evidence has led up to that, and where does it stand today? So, um, ever since the beginning of human civilization, people have had ideas about what the universe is really like. So, for example, down here I have ancient Jewish cosmologies of the universe, and I also have ancient Egyptian cosmologies. And what you can see is that their view of the universe was pretty much the same. They thought of there being a dome above heaven with the waters above it. That's where the rain came from. The Egyptians pretty much thought the same thing, right? The sky was a dome, and there was water above it. So that's where the boats come from. But they thought that every single different one of these things was a god, like the earth was a god, and the sky was a god, and the sun, Ra, was a god. So was the waters above. Now, this view of the universe, it kind of died with those cultures. But up until the 20th century, almost all scientists thought that the universe was eternal, meaning that it never began to exist. It's never going to end existing. The universe just is. It's existed for all eternity. Now, that was until the Big Bang Theory came along. So the Big Bang Theory is the theory that the universe began as a point and has been expanding ever since. And so we're going to have to elaborate on what we mean by this. But the important thing to understand is that this establishes, or at least supports, the idea that the universe began to exist at some point in the past. Now, the Big Bang is not an explosion into space, it is an explosion of space itself. So when we say that the universe had a beginning, what we mean is that time, space, matter, energy, all of this did not exist before the Big Bang. The Big Bang is actually the emergence or the existence or the coming into being of time and space and matter and energy itself. Now, the reason why it's called the Big Bang Theory is that because at the beginning, the universe was squeezed into a small, hot, dense area known as the singularity. So imagine everything in the universe today squeezed into something the size of a pea. And that's what we would think the singularity is. Now, there are three main pieces of evidence that support this idea. And what you can see from this chart is that about 13.7 billion years ago, that's when we have the Big Bang, whatever that means. But what we see here is that the universe itself is the thing that is coming into existence. So the universe doesn't just go on forever in the left direction, it actually has a beginning time, it has a beginning point. And before that, it did not exist. So the first reason why that we think the Big Bang theory is true is because of Einstein's theory of relativity, and so this is in the early 1900s. And what Einstein proposed was that space and time are really the same thing, mathematically speaking. And what this means is that time and space are kind of in this mesh or this fabric known as space time. And the reason why things with mass are gravitationally attracted to each other is because things with mass bend space time. So, with this picture down here, this fabric, this grid, is space time. And the sun, because has so much mass, it is actually bending the curvature of space. And that's why the sun has such a large gravitational pull. Now, this created a problem for Einstein because if the universe weren't, he realized that if the universe weren't spreading out in some way, if the planets and stars and the galaxies, if they weren't expanding, that means that everything in the universe should be clumped together by now, right? The gravity, they should have been caught in each other's gravity and everything should be clumped together. Now, this means that the universe must be expanding in order to match what we observe because the universe is not clumped together. It's not. And so that means that the universe must be expanding. But the thing is that Einstein didn't like that idea for philosophical reasons. So he proposed something called the cosmological constant, and that countered the gravity and kept the universe static. Now, he didn't know what this mysterious force was that kept the universe static, but he thought it existed because it looked good. So here's a picture of Einstein, and his cosmological constant are these red arrows that are kind of keeping the universe from crunching in on itself. Now, another thing that we saw was from Erwin Hubble. The Hubble Space Telescope is named after him, and he was an astronomer. He had a big telescope, and the light of galaxies far away from us is shifted toward the red end of the visible light spectrum. Now, if you don't understand that, you're going to want to watch the previous lecture on about light. So, if things are moving away from us, then their light appears shifted in the red direction. Now, red light has a long wavelength and a low frequency. So that means that when it's moving away, when something is moving away from us, the light stretches, and that is because of the Doppler effect, and we've talked about that before. Now, this means that galaxies that are red shifted are moving away from us, and that the universe is expanding. And this is what he discovered. He looked at a bunch of galaxies and stars and things like that, and he discovered every direction he looked, the light was becoming more and more red shifted, meaning that these things were moving away from us. Here's just a couple of pictures here. That's of Erwin Hubble. And then over here is the Doppler effect. This is something you've seen before. The third thing that was discovered is something called the cosmic background radiation. So if the universe really did begin in the past in a very small, hot, dense sphere, that means that there must have been a lot of radiation at the very beginning of the universe. It must have been very hot. And that radiation should still fill the universe today, because as the universe expands, that heat, that radiation is cooling down. So maybe we can still find that radiation today. And it turns out we can. As the universe expands, we would expect the radiation to lose energy and cool down via the Doppler effect. Now, in 1965, there were some scientists on the East Coast working for Bell Laboratories, and they were working on a way to do radio communications to satellites. And so they had what's called a radio telescope. It's really just a big radio antenna, and they couldn't figure out why they were getting so much background noise in their antenna. No matter which way they pointed their radio telescope, they always heard the same background noise. Now, what they discovered was the cosmic background radiation. This is the heat left over from the Big Bang, or some people might call it the smoking gun of the Big Bang. This is kind of a picture of the background radiation. So the universe does have a temperature. It's at about 2.5 Kelvin. But this is the radio telescope that they used to find it. So these three main lines of evidence help us think that the universe is currently expanding, that it came into existence at some point in the finite past, and that the universe began to exist. It hasn't always been here.